Hello students, in the previous section I have done 13a from class 10 textbook and today I am doing 13b. And here question number 1 is the dimensions of a metallic cuboid are 100 centimeter into 80 centimeter into 64 centimeter. It is melted and recast into a cube. Find the surface area of the cube. Now here as given in the question, the dimension of a metallic cuboid is 100 centimeter into 80 centimeter into 64 centimeter. So this is length, breadth and height. This cuboid is melted and recasted in the form of a cube. We have to find the surface area of this cube. Now here length is 100, breadth is 80 and height is 64 centimeter. In case of cube, we can consider let each edge be x centimeter. Now since the cuboid is melted and recasted in the form of a cube, therefore volume of the cuboid must be equal to the volume of the cube. So we can write since the cuboid is melted and recasted into a cube, therefore volume of cube equal to volume of cuboid. Now volume of a cube, we know it is side cube. Each side we have considered x, so it will be x cube equals to length into breadth into height, because volume of a cuboid is length into breadth into height and volume of a cube is side cube. So we can write x cube equal to L into B into H. X cube equal to 100 into 80 into 64. Now we can write 100 into 80 can be written as 8 into 10 and 64 is 8 square. So it will be 8 into 8 square, 8 cube into 100 into 10, 1000. So 8 cube into 10 cube. So we can write x equals to cube root of 8 cube into 10 cube. This cube and cube root will cancel. So we are going to get x equals to 8 into 10, x equal to 80 centimeter. Now we have to find the surface area of the cube, and surface area of the cube formula is 6 into side square. So it will be 6 into 80 square. 6 into 80 square is 6400. After multiplying it will be 38400 centimeter square. Therefore surface area of the cube is 38,400 centimeter square. Question number 2, it is given a cone of height 20 centimeter and radius of base 5 centimeter is made up of modeling clay. A child reshapes it in the form of a sphere. Find the diameter of the sphere. Here this cone is given whose radius is 5 centimeter and height is 20 centimeter. This one is remodeled in the form of a sphere. Suppose here radius is r, we have to find the diameter of this sphere. So in case of cone we can write radius r is 5 centimeter and height is 20 centimeter. In case of sphere we can consider let r be the radius. Now since this one is reshaped in the form of a sphere, so volume of sphere must be equal to volume of cone. Since the cone is reshaped into a sphere, therefore volume of the sphere must be equal to volume of cone. We know volume of sphere is 4 by 3 pi r cube and volume of the cone is 1/3 pi r square each. Here we have taken two different variables because radii are not equal. So r cube is 1/3 pi r square each divided by 4 by 3 pi. These 3 and 3 can be cancelled. So we got r cube equals to pi r square h divided by 4 pi. Pi and pi cancels. So r cube equals to r square, radius is 5. So 5 into 5, height is 20 divided by 4. Now 4 5 are 20. So r cube will be 5 into 5 into 5, which will give 5 cube. So radius equal to 5 centimeter. Now in the question we have to find the diameter of the sphere. So diameter will be double of radius. So diameter of the sphere is 5 to the 10 centimeter. Question number 3. Metallic spheres of radii 6 centimeter, 8 centimeter and 10 centimeter respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. Suppose these are the 3 smaller spheres. These 3 are melted and we got the bigger one. So we can write in case of first sphere, let radius r1 be 6 centimeter. In case of second sphere, let radius r2 be 8 centimeter. And in case of third sphere, let radius be r3 which is 10 centimeter. Now these 3 spheres are melted and we got this bigger one. So in case of the bigger one we can write in case of single solid sphere, let capital R be the radius. Now just because these 3 spheres are melted and we got this one, so volume of these 3 together will be equal to the volume of the bigger one. So we can write since the metallic spheres are melted to form a single solid sphere, therefore volume of the new sphere will be volume of first sphere plus volume of second sphere plus volume of third sphere. We know volume of a sphere is 4 by 3 pi r cube. Since in case of new sphere, we have considered radius to be capital R, so it will be 4 by 3 pi r cube equals to 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube. So 4 by 3 pi r cube equals to, from these three I can take 4 by 3 pi common. We are left with r1 cube plus r2 cube plus r3 cube. So r cube equals to 4 by 3 pi r1 cube, r2 cube, r3 cube divided by 4 by 3 pi. These two will cancel. So we are left with r cube equals to r1 cube plus r2 cube plus r3 cube. These three values are given, which is 6, 8 and 10. So we got r cube equals to 6 cube, 8 cube and 10 cube. 6 cube will give 216, 8 cube will give 512 and 10 cube is 1000. So after adding it will be 1728. Now 1728 is the cube of 12. So we can write r is cube root of 12 cube. These 3 and 3 cancels. So we are going to get r equal to 12 centimeter. Therefore required radius of the resulting new sphere is 12 centimeter. In question number 4, it is given a solid metal cone with radius of base 12 cm and height 24 cm is melted to form solid spherical balls of diameter 6 cm each. Find the number of balls thus formed. So here it is given one cone whose radius is 12 cm and height is 24 cm. In case of each spherical ball, it is given the diameter is 6 cm. So radius will be 6 by 2, 3 cm. Suppose there are n number of balls. So we can write let the number of spherical balls be n. Since the cone is melted to form spherical balls, so volume of balls must be equal to the volume of cone. So volume of all the balls will be equal to the volume of cone. So we can write volume of spherical balls equal to volume of cone. How many balls are there? We don't know. We have written n. So n into volume of each sphere equal to volume of cone. So n into 4 by 3 pi r cube. In case of sphere, we have considered capital R to be the radius, equal to 1/3 pi r square each. So n equals to 1/3 pi r square each divided by 4 by 3 pi r cube. These 3 and 3 can be cancelled. So we got n equals to pi r square each divided by 4 pi r cube. Pi also can be cancelled. So n equals to r square. R is 12. So 12 into 24 divided by 4 r cube. 4. Capital R is 3, so it will be 3 into 3 into 3. If I cancel, then n will be 4 into 4 into 2. 4 4 just 16 to the 32. Therefore, number of balls formed will be 32. Now question number 5. The radii of internal and external surfaces of a hollow spherical shell are 3 cm and 5 cm respectively. It is melted and recast into a solid cylinder of diameter 14 cm. Find the height of the cylinder. In this question, one spherical shell is taken, it is melted, and after melting we got this cylinder. In case of spherical shell, external radius is 5 cm and internal radius is 3 cm. So we can write in case of spherical shell, external radius r1 is 5 cm, internal radius r2 is 3 cm. Now after melting we got this cylinder. In case of cylinder, diameter is given 14, so radius will be 7. And its height is to be calculated. Now since the spherical shell is melted and recasted into cylinder, so volume of cylinder must be equal to volume of shell. In case of cylinder, formula is pi r square h. This is the volume of a cylinder equal to volume of shell. So it will be external volume minus internal volume. So it will be 4 by 3 pi r2 cube minus r1 cube. So h equals to 4 by 3 pi r1 cube minus r2 cube divided by pi r square. Pi and pi can be cancelled. So h will be 4 by 3. These 3 we can write it here. R1 cube, that is 5 cube minus 3 cube divided by capital R square. Capital R is 7. So 7 into 7. So h equals to 4. 5 cube is 125 minus 3 cube is 27. 27 divided by 3 into 7 into 7. So h is 4 into 125 minus 27 is 98. And here 3 into 7 into 7. 7 7 is 49. 49 2 is 98. So after cancelling 98 with this 2, we got 2. So h is 4 2 is 8 by 3. So height of the cylinder is 8 by 3, which is 2 by 3 centimeters. Question number 6, it is given how many balls, each of radius 1 centimeter, can be made from a solid sphere of lead of radius 8 centimeter. This is the bigger sphere whose radius is 8 centimeter. After melting, we got this type of small balls of radius 1 centimeter. We have to find how many such balls are there. So in case of solid sphere, radius capital R is 8 centimeter. In case of small sphere, radius small r is 1 centimeter. Suppose there are n number of balls. Since the smaller balls are obtained by melting the bigger sphere, so we can write volume of small balls equal to volume of solid sphere. Now there are n number of balls, so n into volume of each ball equal to volume of the solid sphere. So n into volume of smaller ball is 4 by 3 pi r cube equals to 4 by 3 pi capital R cube. So n is 4 by 3 pi r cube by 4 by 3 pi smaller cube. 4 by 3 pi can be cancelled. So we are left with n equals to capital R cube minus smaller cube. Capital R is 8 cube, smaller is 1, so it will be 1 cube. So n equals to 512, because 1 cube is 1 and 8 cube is 512. So number of balls is 512. Question number 7. What length of a solid cylinder 2 cm in diameter must be taken to recast into a hollow cylinder of length 16 cm, of external diameter 20 cm and thickness 2.5 mm. So this is the solid cylinder whose diameter is 2 cm and height is h. Now using this one, we got this hollow cylinder where external diameter is 20 cm, height is 16 cm and thickness is 2.5 mm. So we can write in case of solid cylinder, diameter is 2 cm, so radius will be 1 cm. Let height of this cylinder be h. Now in case of hollow cylinder, it is given length, which we have considered capital H, is 16 cm. External diameter is 20, so external radius will be 20 by 2, 10 cm. Thickness is 2.5 mm. 2.5 mm means 2.5 by 10 cm, which will give 0.25 cm. This thickness is 0.25 cm. Since it is given in millimeters, so we have to convert in centimeter. So external radius minus thickness will give internal radius. So internal radius R2 will be external radius minus thickness, which will give 9.75 cm. Now since solid cylinder is melted and recasted into the hollow cylinder, so volume of solid cylinder must be equal to volume of hollow cylinder. So pi r square is equals to external volume minus internal volume. So pi r1 square h minus pi r2 square h. So h equals to, from here I can take pi and h common, we are left with r1 square minus r2 square divided by pi r square. Pi can be cancelled, so h equals to r1 is 10 square minus r2 is 9.75 square, h is 16 and smaller is 1, so it will be 1 into 1. So h equals to 10 square is 100 minus 9.75 square is 95.0625 into 16. If you subtract, it will be 4.9375 into 16. After multiplying, it will be 79. Therefore, height of the solid cylinder is 79 cm. Question number 8. 50 circular plates, each of diameter 14 cm and thickness 0.5 cm, are placed one above the other to form a right circular cylinder. Find its total surface area. As given, in case of each circular plate, diameter is 14 cm, so radius will be 14 by 2, 7 cm and thickness is given 0.5 cm. In this way, there are 50 plates, and if we keep one on top of other, ultimately we are going to get a cylindrical structure. So in case of this right circular cylinder, radius will be 7 and height will be 50 into 0.5, because thickness of each plate is 0.5 centimeter. So thickness of 50 will be 50 into 0.5, that is 25 centimeter. Now we have to find the total surface area of this cylinder. Formula is 2 pi r h plus r. 2 pi is 22 by 7 into r is 7, h plus r, height is 25 plus 7, 7 and 7 cancels, so 44 into 32, which will give 1408 centimeter square. Therefore, total surface area of the right circular cylinder is 1408 centimeter square. Question number 9. A 16-meter deep well with diameter 3.5 meter is dug up and the earth from it is spread evenly to form a platform 27.5 meter by 7 meter. Find the height of the platform. Here in case of the well which is cylindrical in shape, diameter is 3.5 meter and height is 16 meter. So 3.5 meter can be written as 35 by 10 meter. If I cancel by 5, it will be 7 by 2 meter. So radius will be half of diameter. So 7 by 2 into 2. So it will be 7 by 4 meter. And here height is given 16 meter. Now whatever earth is collected from it, it is spread evenly to form this platform. Here it is given length is 27.5, breadth is 7 meter, height is not known. So in case of the platform, length L is 27.5 meter, breadth is 7 meter and height is not given. And we have to calculate this. Since the earth collected from the well is spread evenly to form the platform which is cuboid in shape, so volume of the platform must be equal to the volume of the earth collected from the well. Now volume of the platform is length into breadth into height, and volume of the earth collected from the well, it will be the volume of the cylinder which is pi r square each. Now length is 27.5, breadth is 7, height is h, equals to pi is 22 by 7 into r square 7 by 4 into 7 by 4 into height is 16. Now 4 just 16, it can be cancelled. 7 can be cancelled. So here we got 27.5 into 7 into h equals to here 11 into 7 into 2. So h equals to 11 into 7 into 2 divided by 27.5 into 7. Again 7 can be cancelled. So h equals to 22 by 27.5. Now if I multiply both by 10, so h equals to 22 into 10, and if I multiply this one by 10, it will become 275. If I cancel by 11, it will be 25, it will be 2. So h is 2 into 10 divided by 25. Again this 10 and 25 can be cancelled by 5. It will be 5 2 ja, 5 5 ja. So h is 4 by 5, that is 0.8 meters. Now if you convert into centimeter, then we have to multiply by 100. So height equal to 0.8 into 100. Now it will be in centimeter, which will give 80 centimeter. Therefore required height of the platform is 0.8 meter or 80 centimeters. And that's the answer. So that's all for today. I have done up to 9 in this video. In the next video I am going to start from number 10 of 13B. Till then, bye bye, take care and wait for the next part.